Imagine standing on a world so distant it takes 5 whole hours for a single beam of sunlight to reach you. The temperature hovers at -230 degrees Celsius, and one trip around the sun takes 248 Earth years. In 1930, a 23-year-old astronomer named Clyde Tombaugh was working at the Lowell Observatory in Arizona. His task was to photograph the night sky and search for anything moving within the darkness. This animation illustrates the blink comparator method Tombaugh used. By rapidly flipping between 2 sky photographs taken days apart, he looked for a single dot shifting its position against the stationary stars, proving he had found a local planetary object. When it came time to name the discovery, an 11-year-old girl named Venetia Burney suggested Pluto, after the Roman god of the underworld. The name stuck, and for 76 years, Pluto was solidified in textbooks as our solar system's 9th planet. For decades, that was the extent of our knowledge. Pluto remained a mysterious, unexamined speck of light on the absolute edge of our maps. Then, in 2006, the International Astronomical Union met in Prague for a General Assembly. They gathered to establish a strict scientific definition of what a planet actually is, and the result shocked the public. This diagram shows the first 2 criteria. A planet must orbit the sun and form a perfect sphere. Pluto meets both. But zooming out reveals the 3rd rule. It must clear its neighborhood. Cluttered with thousands of icy Kuiper Belt rocks, Pluto failed this final test. The IAU demoted Pluto to Dwarf Planet status. The decision was met with immediate pushback from both the public and members of the scientific community, who argued the new rules were too restrictive. While the world argued over whether Pluto was a real planet, a NASA spacecraft was already halfway across the solar system, carrying instruments that would soon render the entire debate secondary to the facts on the ground. NASA's New Horizons spacecraft launched in 2006. It left Earth at a record-breaking speed of roughly 58,000 kilometers per hour, faster than a speeding bullet. Even at that speed, the journey took 9.5 years. The probe traveled through a dark, empty void, crossing nearly 5 billion kilometers of space to reach its target. In July 2015, New Horizons finally arrived. It streaked past Pluto at a distance of 12,500 kilometers, capturing thousands of high-resolution images in a matter of hours. The data returned to Earth upended every previous assumption. Researchers didn't see a dead, cratered rock. They saw a world that was geologically active and startlingly complex. The most famous discovery was the heart, a feature officially named Tombaugh Regio. It is an unbroken plain of nitrogen ice, so large it could contain 2 states the size of Texas. Adjacent to this heart are mountains of water ice rising 3 kilometers into the sky. At these temperatures, the water ice is as hard as rock, allowing nitrogen glaciers to visibly creep and flow between the peaks like slow-moving rivers. Pluto also has a distinct reddish-brown hue. This color is caused by tholins, organic compounds created when ultraviolet light strikes methane in the atmosphere, raining down a layer of dark soot onto the surface. This diagram illustrates Pluto's breathing atmosphere. As Pluto gets closer to the sun, surface ice warming turns into gas. As it moves away, that gas freezes, precipitating back down to the surface as nitrogen snow. Pluto even shares a unique relationship with its largest moon, Charon. The moon is so large that the 2 bodies actually orbit a common center of gravity located in the open space between them, acting more like a binary system than a planet and a moon. The presence of moving glaciers and rising mountains on such a small scale proves that geological energy isn't reserved only for the largest planets in our system. The most significant discovery from New Horizons isn't visible on the surface. It is hidden deep within the planet's interior. Look at this cutaway of Pluto's interior. Geologists believe radioactive decay in the rocky core generates enough heat to warm the surrounding ice. This likely melts the bottom of the ice crust, creating a vast liquid ocean sandwiched between the rock and frozen surface. On Earth, we have found that life can thrive in pitch-black oceans around hydrothermal vents, using chemical energy rather than sunlight to survive. It is a striking irony. The same world stripped of its status for being too small and distant now shares a rare characteristic with life-bearing candidates like Europa, a liquid interior protected by a shell of ice. Proving the existence of life in such a remote environment would require a landing mission with technology that is currently beyond our reach. But the data we already have shows that Pluto's value isn't tied to an arbitrary title. Whether we call it a planet or a dwarf planet, its geological activity remains just as profound. Pluto stands as the most complex world yet discovered in the Kuiper Belt frontier, providing a template for understanding the thousands of icy objects that exist in the outer reaches of our system. Pluto demonstrates that scientific definitions can change, but the data we gather from 5 billion kilometers away is what truly defines a world's significance. Our map of the solar system is still being written.